Hello AP Calculus, and welcome to this short video on rational functions. So we're going to practice finding the x and y intercepts of rational functions. Hopefully we can get to graphing them easier once we are able to do these key steps. So the only notes that you need for this section are finding x and y intercepts, and these rules are true for any functions. So to find the x-intercept, we'll always set the function, the whole entire function, equal to 0. So to find the x-intercept, it's the same as setting y equal to 0, because the function is y. To find the y-intercept, we'll set the x value equal to 0. So notice the pattern. You always, if you're looking for one intercept, you set the other variable equal to 0. So what this does, once we've set the function, for instance, or the y value equal to 0, we can solve for x. X comma 0 will give us an x-intercept along the x-axis. When we set our x value equal to 0, we're able to solve for the y value that corresponds, and that gives us a point somewhere along the y-axis. So please know these notes. Okay, let's get into it. So for number 4, we're given this kind of funky looking rational expression, and it says for part A to find the x-intercept. So I'm writing down, this is my work. These are the expectations as far as what you will show on your homework. Exactly all the steps I show in class, that's what I expect you to show on your homework. This is AP level work, and the AP does care about showing your work. So if it takes me 5 steps to do a number in class, it should take you 5 steps to do it on your homework. In case you were confused about that, that's the expectation. So you on your homework will write x-intercept, and you will write this first step. To find the x-intercept, we set the function equal to 0. In our next step, we can substitute the function. The function is -4 over x minus 1 whole squared plus 1, and that's now set equal to 0. Okay, so in our next step, notice that we're basically now given, we're dealing with a rational function, and we're solving this rational equation. And to solve a rational equation, remember from class, we have a number of steps. Our first step is to find the least common denominator. And since we're given an equation, meaning we have an equal sign, we can multiply both sides by the same thing and keep the equation true. So in this case, we're going to find the least common denominator, which is x minus 1 whole squared. And then we're going to clear the fraction by multiplying every term by the least common denominator. When we do that, the denominators will magically disappear. So let's try it. I'm going to multiply every term by my least common denominator, which is x minus 1 squared. So 1, 2, 3 times. I have 3 terms. So x minus 1 whole squared times the 4. X minus 1 whole squared gets multiplied with the 1, and x minus 1 whole squared gets multiplied with the 0. In our next step, we're going to clear the fractions, so this denominator disappears, leaving me with -4 plus 1 times x minus 1 whole squared equals 0 times anything is just 0. So from this step, I just have a quadratic, and we can solve it. From there, this will be x squared minus 2x plus 1 equals to 0. Combining our like terms. And then lastly, we can factor this. So this factors pretty nicely. I didn't have to use the quadratic formula. But if it didn't factor, I would have to try the quadratic formula. And so just be prepared for that extra level if it comes to it. X equals +3 and x equals -1. So I'm really close to my answer, but the question actually asked me for the x-intercepts, meaning they're looking for a point. So my final answer is really x-intercepts are 3, 0 and -1, 0. So when we set our y value equal to 0, we got our x values here. In the last step, we're combining all that information into two x-intercept points. And we're done. Okay, let's do part B now. Part B says to find the y-intercept. So part B says to find the y-intercept. Again, what I'm writing on my paper, I should see on yours. This first problem took starting here, it took 1, 2, 3, 4, 5, 6, 7, 8 steps. So I should see 8, maybe like 7 or 8 problems, 7 or 8 steps in your homework assignment. Okay, you shouldn't be skipping too many steps. So part B, let's find the y-intercept. So for the y-intercept, the work that we're showing is x equals 0, which means that instead of writing down f of x, we're going to write f of 0 equals. So actually, you can even just go straight to this step. F of 0 equals, because we know we're setting our x equal to 0 there. So instead of negative 4 over x minus 1 squared, I'm writing negative 4 over 0 minus 1 squared. And then I think it's a plus 1, yeah. Cool, we just have to simplify this. So that's going to be negative 4 over negative 1. 0 minus 1 is negative 1. Squared is positive 1. And then this becomes negative 4 plus 1, which is negative 3. Easy peasy. So now, when we set x equal to 0, our y value was negative 3. So our final answer here is y-intercept of 0, negative 3. And we're done there. Let's move on to part C. Okay, part C says find f of negative 3 and f of 5. So first we'll do f of negative 3, which is, actually let me clear out some of this work. Pause the video if you need to take this work down because I am now deleting it. Okay, so f of negative 3 equals negative 4 over, and I'm plugging in negative 3, minus 1 whole squared plus 1. Step by step, negative 3 minus 1 is negative 4. And then when I square it becomes 16, positive 16. There's still a negative 4 on top. That simplifies to negative 1/4 plus 1. And the last step I can use the fraction trick. 4 times 1 is 4, minus 1 is 3. So my answer is 3 over 4. Let's do the second part of that problem, f of 5. So now we're just plugging in 5. You can pause the video and try it yourself. So you should have gotten the same exact answer, actually, this time. So it's good to know that if I were to graph this, let's see what we know so far. I think our points were x-intercepts at 3 and negative 1. And then we had a y-intercept at negative 3 also. Okay, so that's what we know so far. We also now know that we have at negative 3 a positive value, and at 5 a value of positive 3/4 as well. So we can start to get an idea of what our graph actually looks like. Actually, I want to show you something right now. So when we have a rational function, the first thing that you would want to notice about a rational function is something called the vertical asymptote. And the vertical asymptote is whatever value you get when you set the denominator equal to 0. So in this case, my denominator is x minus 1 squared equal to 0. So I'll find my vertical asymptote by solving for x. So I'm going to take square roots on both sides. I'll get x minus 1 equals to 0. And then solving for x, I see that my vertical asymptote is at x equals positive 1. Meaning that if I were to plug in 1 here, I'll get negative 4 over 0. And I know I can't divide by 0, therefore the graph doesn't exist at x equals negative 1, at x equals positive 1. So we indicate that by drawing these dotted lines. And so now, if you've never seen a horizontal, irrational function before, you can start to get an idea of what makes them kind of trippy, which is they have multiple pieces. And that's what this this rational function actually looks like. Okay. Let's do the last part, which is part D. So do you have to graph for tonight's homework? No, you don't have to graph. I just wanted to show you, just expose you to this idea. Okay, so let's do part D. It says solve f of x equals negative 1. Well, f of x is this function, negative 4 over x minus 1 squared, plus 1. That's f of x. And if I'm setting it equal to negative 1, then that's what my next step should look like. So we're solving this for x. The first thing I'll do is move that 1 to the other side. Now I can see that I am kind of stuck, so I want to clear the fraction. I'll multiply both sides by the least common denominator. That will clear it for me. And now I'll solve this rational function. So I have negative 4 equals negative 2. If I were to box this, I'd get x squared minus 2x plus 1. And by the way, I'm doing this in my head quickly using this rule that we learned from class, which is when we're squaring a binomial, we square the first term, we square the last term, and the middle term is a times b times 2, because it's going to appear in this box. In this box, you're going to add them up. You're going to double it. So let's continue. I have negative 4. Actually, let me go back red. Negative 4 equals, distributing, that's negative 2x squared plus 4x minus 2. Move everything to the same side. Remember, you want to set this guy equal to 0 so we can factor. So I have negative 2x squared plus 4x. When I add the 4, I get plus 2 equals 0. From this step to factor, you might go straight to magic x, but I'm warning you, that would be a mistake. Do not go to magic x first. You always check if you can factor by GCF. So I'm noticing that I can take out a 2, but also another key point, if there's a negative in front, now this is super important. If there's a negative in front, you've got to pull out the negative. So I'm going to take out a negative, and I'm going to take out the 2. Then I'm left with x squared. Now, by taking out the negative, all my signs will flip, so that'll become minus 2x, and this plus 2 will become minus 1. And I can check it by redistributing in my head. Negative 2 times x squared gives me negative 2x squared. Negative 2 times negative 2x gives me positive 4x. That's good. And then the negative 2 times negative 1 gives me a positive 2. Good to go. Now I'll see if I can factor this guy. So I need two numbers that multiply to... Okay, at this stage you can ignore the negative 2 on the outside. It's not part of our magic x. We're only focused in here. So I need two numbers that multiply to negative 1, but that add to negative 2. The only numbers that multiply to -1 are -1 and +1, and those will always add up to 0. So I have to use the quadratic formula. So a equals 1, b equals -2, c equals -1, and the quadratic formula says that x equals -b, so that'll be negative b is going to be +2, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And like I've said before, the very first thing I do for quadratic formula problems is I check the sign of the middle guy. Since it's a negative and there's another negative, the first thing I'm going to do is write a plus sign. Why? Because that's the most common mistake that everybody makes. It's just a simple oversight, getting the sign wrong. So next we have 2 plus or minus the square root of, that would be 4, and I know that's going to be plus 4. Next we get 2 plus or minus root 8 all over 2, and breaking down root 8, the smallest number that goes in is 2 4 times. 2 goes into 4 2 times, and 2 does not break down, so I stop. I can say I can pull out a 2. There's 1 2 left over, it's all over 2. And in the next step, I'll break this up. That's 2 over 2 plus or minus 2 root 2 over 2. Well, this guy becomes a 1. And you can't cancel a radical with a regular number, so the radical stays the same. But this 2 and this 2 cancel, leaving me with 1 plus or minus root 2. So to answer the question that we started at, which was at which y values, or rather at which x values is our y -1, the answer is at x equals 1 plus root 2 and at 1 minus radical 2. Okay, I hope that video was helpful. Good luck. You're doing number 5 for your homework.